what you got was the Android OS. It is nothing but your Linux OS with a couple of things added on. Now, you have the OS now, and via the drivers we can interact with the hardware, but that's not enough. That's not enough. Remember, what was needed was the ability for any developer to be able to build app like using a programming language like Java, which means what was needed was these hardwares cannot be interacted with directly using drivers. That is too low level in nature. So that means these drivers should be exposed via services so that the applications can consume the services itself rather than talking low level to the drivers. So what did this guy do? Andy Rubin and his team, they envisaged a next layer in the stack which exposes all the functionalities of the hardware and the OS to the above layers by abstracting it. And what layer did he create? What was it he created on top of this? Mainly, first and foremost, what he added on are a set of open source libraries. There were a plethora of open source libraries in the world which were very, very popular. So these guys did not reinvent the wheel. They just took the the open source libraries and they packaged it. Like what? Tell me, which is the most popular? Scratch that. Which is the most popular database in the world? 6 stones. Oracle, isn't it? Most popular database in the world. Which is the most used database in the world? Oracle or MySQL? Your SQL. Just kidding. MySQL or Oracle, guys, most used database in the world? No. It is neither that nor Oracle. It is something called SQLite. Okay? SQLite is an open source database which is used more than any other database, and there is a reason why we have never encountered it. It is actually used the most, but we have never encountered it, at least personally, individually, face to face, because this SQLite database is always used as an embedded database. Your Oracle, MySQL are standalone databases. You install the database separately and you have applications use them. Whereas SQLite database comes embedded inside applications. Like, have you used Windows Excel? Have you used Windows Word? Have you used Chrome? Have you used any Mozilla Firefox browser? If yes, then you have used SQLite, because all of these softwares internally embed SQLite database. So obviously, when building a mobile ecosystem, is there a necessity to store data persistently and permanently or not? Yes, for which we need a database. And they did not invent a database from scratch. They took the most open source, most powerful, most performant used database in the world, SQLite. Similarly, tell me, a mobile ecosystem should have a capability for multimedia. That means you need the ability to be able to run your audio and video, etc. What open source libraries power animation and video, media, etc.? Come on, guys, everybody knows this. The open source libraries built on C++, which is powering the entire animation industry. OpenGL, right? So OpenGL got added for animation, 2D, 3D animations, right? And then you have all your libc libraries. You have your the media libraries. I forget its name right now, it's not coming to me. The media libraries using which you can play your MP3s and MP4s and WAVs and AVIs and whatnot. Again, they are all open source libraries. You see, you need the players to be able to run all these things. So they took all of these open source libraries and put it together into this stack. And what do these open source libraries do? They will interact with the OS and the drivers to interact with the hardware to give the services of the hardware to the above layers. So you got a hardware and you got your libc is your font family. You need fonts, different types of font implementation, isn't it? So nothing was implemented from scratch. It was just taken from other open source libraries which are there and put together in a package, so to say, right? So like this, several libraries got added on. But now, what is needed? At the top, what should be there, which are user facing, are apps. But apps should be built, should be easy to build, and these apps cannot directly communicate with these open source libraries. They are still a little low level and they are built on C++. And what was the programming language that was chosen to power the Android platform was your Java language, isn't it? So today we have a variety of choices. You have, what is the latest entrant to Android application development, which language? Kotlin, isn't it? And you can build it in natively as well. Having said that, Java was the original chosen programming language. So which means people want to develop using Java, but all of these open source libraries are built on C, C++. So how to consume them? That's why. And to build Java applications, to run Java applications, what is it we need? To run a Java application, what software you need? JVM. And to be JVM is not just enough. What is it you need? Runtime library. So we need runtime library with JVM, nothing but called JRE, isn't it? So what was built was a JRE. Remember in the earlier discussion of introduction to Java, we discussed what makes Java powerful is that new JREs and JDKs can be built for newer platforms, right? So this is now a new platform. Android is a new platform. This kind of hardware did not exist. This kind of OS did not exist. But they wanted to run Java applications on it. That means you need runtime library for it. You need JVM for it. So they built a JVM and a runtime library. How? Because Java is an open source language which gives us documentation, right? Called Java language specification and JVM specification. Using JVM specification, what software can be built? JVM. Using Java language specification, what software can be built? Runtime library. Combining the two, you get JRE. So what got built? What they built is what is called ART in short. It's called Android Runtime. What does this Android Runtime contain? A virtual machine plus runtime library. So the JRE of sorts, right? So the VM and the runtime library was built from scratch, and the runtime libraries, there were additions to this runtime library which now could interact with open source libraries. And the open source libraries interact with the OS and interact with the drivers to give you the features of the hardware to the above layers, which means what became an ability now, if an application is going to be built, can we now utilize all the services of the hardware and the OS using this runtime library or not? Which means what you don't have to build is C, C++ calls. You can directly use Java calls, Java classes, which interacts with open source libraries, which will further interact with your OS and hardware. But then, again, to build an application takes a lot of effort, because primarily what kind of applications can you build? Should you build on mobile platforms or GUI based? So we need a graphics engine. We need the ability to showcase a window. We need an ability to have an application bar. We need notifications. We need background services. We need the ability to run swipe in, swipe out, move, animation. Nobody can build all these things from scratch. So what was added on top of this layer is the important layer for us called Android Application Framework. Android Application Framework layer. And what is a framework? Those of you who know, tell me what is a framework. Framework is a half-built solution. It's a half-built solution which addresses a particular space, particular domain for us to build applications more quickly. So it's already half-built, means we don't need to build from scratch. We build on top of it, right? So Android Application Framework consists of services, consists of notifications, consists of activities, consists of windowing, toolkits, and so on and so forth. All of these are what are called components of Android. We'll talk about this. So components of Android. Now, on top of this sits your applications. And the applications comes in three flavors. There are three flavors of applications. There are native applications. There are third-party applications. There are hybrid apps is also an interesting classification, but I'm going with the stack that Android had released earlier on: native applications, third-party applications, and your what is the name? Google applications, right? Which means the vendor applications. So I'll just call it Google Apps until I get the right word for it. Google Apps, right? So applications can now be built using a variety of programming languages, but if you use Java, we have now a framework ready for us, so that, and this framework, by the way, this framework is primarily built on Java itself. So that means you have a framework ready for us which we can learn and build on top of. It's already half built and half ready, so we need to build only the other half. And here is the beauty: the applications can be built on Java applications can be built by the Google itself who owns Android, or another application can be built which are native apps. Native apps means these native apps directly communicate with open source libraries. You can build it on C, C++. For particular types of apps that we want to build, we want to bypass this application framework. We want to bypass the Java. We can directly communicate with open source libraries and build apps as well. Like for example, your Truecaller. You use Truecaller, Truecaller to find out, as soon as a phone call comes, it tells you who is calling, isn't it? And if you look at the Truecaller, they have built native app, so which listens to events that occur at the OS level. When a phone call is coming, so to superimpose your phone calling with the Truecaller screen. It's actually a complex thing to do. It's not simple. It cannot be done directly with Java. You have to build something called native app for it. Bottom line, native apps can directly build on C, C++. Third-party apps and Google apps are there. That means already pre-packaged apps are implemented in the Android ecosystem. You have Google Maps, you have YouTube, you have browser, right? I forgot the browser. Which is the most popular browser technology that is used open source? No? Your Chrome, your Safari, your whatever other, which are the other popular softwares? I mean browsers, not Internet Explorer. Firefox then? So Firefox, Opera, your Chrome, all of this are built on open source browser called WebKit. They are not built from scratch. They are built on this open source technology called WebKit, right? So they implemented WebKit. So now when you install, when you look at the apps that are there, you already get a very functional browser. You get YouTube for video. You get your Google Maps for location. You get Google Mail for mail. You obviously get Google Search. All of these are pre-packaged apps that are there. And of course, what we can install are third-party apps. The good thing about Google and the good thing about Android is Google people don't get extra libraries. They don't get extra privilege for building apps. Whatever is the framework that is available, the same framework is used by Google people to build their Google apps, is the same framework that is available for us to build apps as well. Not the same case with Apple. If you are an Apple developer, Apple also gives you a framework to develop applications. It gives you libraries. But what libraries you have access to and what libraries Apple developers in the Apple company have access to are different. They have access to more libraries. This is most or no. That means Apple developers, the kind of apps they build, we can never build because they have access to libraries we don't have access to. Whereas Google and Android is all about democratization, right? Which means the same application framework, the same runtime library is available for Google developers also and us also. So that is the reason why Android follows a open source ecosystem where what application can you replace in an Android mobile phone? Like you have caller apps, right? The Google apps that come already. You have a Google caller app, a contact management app, an SMS app, a Google map, a YouTube and so on and so forth, right? What of these apps can be replaced? Yeah, no, what of these core apps these are core apps, right? What of these can be replaced? Can you replace them or can you not replace them? Or you can replace anyone now. That's the power of Android, right? It does not mandate that this company's app, this vendor's app has to be used. Not like in iPhone, you see. In iPhone, you can't remove the caller app. You have to have that caller app, right? And certain apps are fixed. You can't change them. Increasingly, it has changed over a period of time because of the backlash of the development community. But in Google, in Android, anything can be changed because everything is an app and everything is built the same way. So anything can be changed with a new one. That's the beauty of it. Anyway, so there are a number of things in the Android application framework which is what a developer has to learn: intents, notification services, activities, location manager, so on and so forth, all of which built on Java, which are exposed to the application developer. Now, this is what forms the application open source software development stack. There's one thing I have not put it down here. I will show you when I show you the schematic. What comes in between these two is called HAL. In short, hardware abstraction layer. You have the hardware and you have an OS. But what comes in between these two is something called as an hardware abstraction layer. Thank you. Hardware abstraction layer, and this hardware abstraction layer abstracts the hardware to the above OS. Now, very quickly, I want you to understand for 5 minutes before we wrap up this discussion. Okay. Okay, so that is this. Now, what keeps changing month on month, year on year, etc. in the mobile world? What keeps changing? Now, hardware capabilities, right? 2 GB RAM becomes 3 GB RAM, your processors become faster, you have other kinds of sensors that are getting added, isn't it? So hardware keeps changing. But clearly, if this Android has been built, if the hardware keeps changing, OEMs are installing this open source OS onto their hardware, isn't it? So what became a need was the ability for a OEM guy to easily build drivers for their hardware and put it installed in the Android OS. And that's exactly what Android guys did, right? They gave an ability to plug in the drivers to the newer hardware that exists. So look at from the OEM point of view, the one who manufactures hardware, what should he do? He can make hardware, he can add new sensors, and for that what Android OS gives is the ability to plug in new drivers. The moment that is plugged in, all the features gets automatically exposed to the above stack, which basically means it became very easy for OEM guys to build new hardware, to evolve the hardware, and to keep upgrading the OS. However, remember, there is a big problem in the Android ecosystem today, that not all the Android vendors, all the Android users are on the same version. What is the latest version of Android? Oreo, right? Android 8, correct now? But how many of you have Android, let's say, how many of you have Android 8? Anybody? Very nice. So you must have bought the phone in the last 2 months or whatever. Fine. You rooted it. Fantastic. So otherwise, most of us don't have Android Oreo. How many of you have Android 7.1 at least? 7.1. Good. I mean, this is what is showing the distribution of Android OS across the world. You know, approximately only about 6% have Android 7.1, right? Most of them are still in Lollipop, you see, and Android 5. And this is the problem, right? And why is this problem there? Is because the OEM guys, they build the drivers and they build a wrapper on to be embedded inside the Android OS. Now every time a new Android OS is released, what should the OEM guys do is build those drivers and incorporate it to the newer Android versions as well. And they don't do it because it is time inducing and it is expensive, which is the reason why you have disruption of the Android OSs now. Everybody's Android device are on different versions. Having said that, I want to open the floor for questions. Before that, if we now need to be an Android developer, let's first understand this. What should we learn? Should we learn the hardware, how it works? Should we learn the OS, how it functions? Should we learn the open source libraries? What should we learn? Remember, we are interested in building apps. So if we are interested in building apps using all the richness of the hardware that are provided, what should we learn? What you should learn is, first what you should know is core Java. You need to know Java programming itself. And you need to know the core Java part of runtime library plus the additional libraries that are added which interacts with open source libraries. Are you with me? So Bluetooth open source library, that's another thing which is a popular open source library that is there. So we need to learn these runtime libraries. You need to know Java, you need to learn the runtime libraries that are additional, plus what else should you learn? The framework, the AAP or AAF as it's called, right? Not AAP, AAF, Android Application Framework. So if you know Java, then learning runtime library and the application framework is not going to be a very difficult ordeal, and we can learn it easily because both of them are Java based itself. So if you learn this much, then theoretically speaking, I and you can build apps. What kind of apps? Any kind of apps. Android apps, but any kind of Android apps. Literally anything. From the WhatsApp to your Google Maps to your anything that you can envision and think of, I and you can sit and build. And what opportunity does this entail? It's not switching on. What opportunity does this entail for us? Why is it exciting for us to learn Android at all? What is the reason for doing so? Well, we already said it. 2 billion people are using it and it's only increasing. I mean, there is nothing in this world that you can do, nothing you can do which the entire world will listen to. You see, how can you do something which everybody in the world can use? Well, today, increasingly there are new forums, like for example, you can make a YouTube video, right? Because it is available and accessible by everybody. Couple of billion people use it. If it becomes really popular, couple of billion people can see your YouTube video. It's unbelievable and unprecedented. Never a point in time in history of humankind could anybody do a movie or a video or anything which everybody in the world had the ability to see. But today it is there, isn't it? But in the same way, if I build a software, how can we make it be available for everybody? One is you can put it on the web, but the problem is web applications are not as usable because they are not as portable as mobile applications are, as mobiles are rather. So which is why mobile apps are the new age currency of application development and a new age way to reach individual consumers, right? Where I and you can sit and build an Android app and have it be reachable and usable by millions of people. I mean, can you think of it? If I and you sit together on a Mac or a Windows machine and build an app and entire India uses it, it's unbelievable, isn't it? How many of you have Narendra Modi app? You don't have our Prime Minister's app only installed, huh? Our Prime Minister has an app, you should install it. I mean, whether you believe in Modi or don't believe in Modi, at the very minimum we need to know what this fellow is doing, whom we have elected, isn't it? We need to know from his mouth, we need to know from media's mouth, we need to know from all the other people as well. There is a Narendra Modi app. I mean, think about it. Okay, there is a BIM app. BIM app, yes, payment app. I mean, think about it. Where an app can be built by a company. You know, BIM app, when a small company built this BIM app, when the government asked them, how long are you going to take to build this BIM app? They said 3. And the government, in its characteristic style, they first thought it is 30 years. You know, because this BIM app is supposed to be used by the entire India, you see. 30 years. Then they said, oh, not 30 years. 3 years. 3 years, nam government correct, no, in another 3 years election is there and whatnot. Yeah, thank you. So, the company was telling 3 days, okay? And the government was taken aback and they said, in 3 days you can build something which entire India can use. And they said yes. And why is that possible? Is because of, you know, the power of smartphone ecosystems available today like Android, right? Anyway, that's the power today, right? Where I and you can sit and develop app and have it be used by the world. And why would we want the world to use it? Not only just for the kicks of it, but we can make revenue, man. I mean, even your Angry Bird developer, Rovio, made only about few $100 million by making a game, Angry Bird, isn't it? Forget about Angry Bird because it was made by a company. You know of Flappy Bird, right? For example, one individual in Vietnam built this game over 2 days and every day his earning was only $50,000. Free app, man. $50,000 per day he made, and this he made for close to a year. I mean, life settled, not only of him, for all his talatalanta generations, isn't it? Jokes apart, such is the provision and possibility that we have, that if you learn Android development, you can impact the world, impact our country, and at the same time, you know, make a killing and a revenue as well. That's one. Second, today, it was not enough to get into the Android world or application development world, mobile application development world, if only end users were using it. Today, who is increasingly building applications for the mobile ecosystem are enterprises. Why is my spelling going wrong all the time? Enterprises, right? So all businesses are now developing apps. It's a no-brainer. This is again history, isn't it? Take it from your Flipkart or to your Amazon, to your Myntra, to your what is that? Swiggy, to your, I mean, these are all enterprise applications, new businesses, right? I mean, take for example Uber and Ola, right? I mean, Uber and Ola can exist today only because of the smartphone. Such a business could never exist a priori, isn't it? Where through the means of your location, through the means of third-party people, you know, people who have cars, anybody who has a car can become an Uber driver, isn't it? If you have 2 hours in between, simply you can go and drop somebody and make money and come back. Such a possibility was not there, because who could become a driver was only who had a business of having driver-based, chauffeur-driven cars. But today, anybody who has a car can become a driver. This is called the Uberization apps, isn't it? So bottom line, all those are possible today. New age businesses are possible today because of the mobile ecosystem. And third, enterprises, existing enterprises, right? They all reach to us now through the apps that are there. And why apps they should build? Because apps are always installed. They can show notifications, whether we like it or not. Big $1 billion sale will be thrown at us, thrown at our face. And this is whether you like to buy it or not. Suddenly you say 50% discount, something is going on. Isn't it? So that's how they can lure us. Bottom line, all enterprises are moving to application development, and Android, since it has 87% of the marketplace, is a no-brainer that every company wants to build applications in. Now, I've been going on for the last 1.5 hours on this. It's time to end this and to open the floor for questions, and more importantly, to see how are we going to be learning these two things, the runtime library and the application framework. Those are the two things that you and I can learn and build applications which the world can use. And the beauty is, it's not only smartphone, it's not only limited to the smartphone, the new age, AR and VR, which is coming up, we can build applications for it. We can build applications for Android Auto and the Wear and so on and so forth. So literally, the world is our market today. And that's the power of the Android ecosystem, isn't it? And the good thing is, even though it's been there for 10 years, these 10 years, couple of million developers have built Android applications, which means the developer ecosystem is very rich. That means any problem that you can think you can face in Android has already been faced by somebody, and in your in different websites, you already have the answers to all kinds of questions. So which means it becomes very easy to develop, best practices are there, architectural styles have already been identified, all kinds of tools have been built. So literally to speak, it is the easiest to learn Android application development today. So we're not late to the party is just getting started. So I will end the introduction to Android here, but now I would like to hear some questions from your side, because still I've kept so many things open-ended. So ask me some questions so that we understand what does it take to build Android apps and the kind of industry that is there today. And increasingly, as you know, if you look at Gartner report as well, mobile application development is on the increasing trend. Mobile apps and web apps are what are increasing day by day. Desktop app development is decreasing day by day. So it's a no-brainer for us to learn application development. Also, to just tell you, till a couple of years ago, a mobile application developer was only a mobile application developer. A web application developer, there was server application developer, client-side application developer. They had different roles. Today, everything is getting blurred. You have to be able to build anything and everything that the company throws at you, right? So that means if some of us are thinking about, should I go towards web, should I go towards mobile, should I do this, should I do that? Well, you should do everything. So you have to learn about a mobile application development and web application development. That is when you can play your role properly in any company for any work that is assigned to you. Now, ask me some questions, please. Anybody? Hello? Yes. What is the difference between? What is the meaning of an open source framework? So open source framework basically means, anything open source means the source code is available for us to see, right? Not necessarily to change, not necessarily to copy, but definitely for us to be able to see. And the good thing about open source is, because nobody owns it, people called committers can add, write code and contribute to the development of open source. People like you and me can become testers and test it, and other people can fix the bugs. So literally, individual people across the world can contribute to the evolution of open source, which is the reason why all open source things evolve faster than something which is not open source, right? Only very few companies like Apple and Microsoft are able to progress in their capabilities even though they are not open source, right? But otherwise, if you see, what is it that has its evolution, increase its pace like anything, are all open source. Look at programming languages. Programming languages like ABAP, which was really capable, never became as ubiquitous as Java, for example. .NET, fantastic platform, literally super platform to develop applications, but it never became as popular as Java. Not open source again. Very recently they are starting to open source things, but because it was not open source, not everybody adopted it, isn't it? So anything which is open source means the source code is available to see for everybody. Anybody can do testing, help in fixing defects. Anybody can add code to it. Of course, there is a process involved, but because the world can add, the evolution of it happens more so. And the best practices of everything is learned are added into open source. Literally to speak, open source, anything moves faster in evolution when compared to non-open source. Now coming to a framework. Framework is a set of softwares or set of programs that are half built for you, so that you can build on top of it, and instead of building everything from scratch, you can build things much more faster. And this framework already implement best practices like design patterns, so that we don't need to implement it, we can build on top of it. I'll tell you what this framework contains, but not today, but in the next class when I formally start off with Android, right? Anything else? Janaga, anything else? Any queries about the Android marketplace, about the development, about the what does it take to learn Android? I mean, there are so many things I have not touched upon yet. So next 15-20 minutes I would want to address your questions. What's the difference between Kotlin language and Java language? Well, Kotlin is a new language which has been introduced with very expressive style of code, very verbose style of code. So there has been an increasing trend over the last 10 years where people are not very happy with the syntax which is imposed by languages like C, C++, Java, right? Where it's extremely verbose. There is a lot of code that you need to write to even accomplish simple tasks. Like you have to, think about just printing hello world to the monitor, right? You have to build a class, you have to have it public, same name as that of the file name, and public static void main, string array args, open brace, close brace, then system dot, out dot, println. In that double quotes hello. All I want is hello to be printed. Ideally, I should be able to say print hello, and it should print hello, isn't it? That all the adambara that is there, all that other thing code that we need to write, it is extremely template-ish, extremely voluminous. Think about how do you make an object do any job in Java, right? You first create an object by calling the constructor, have a reference, point to it, pass data to the constructor, then call setter methods. After that, you call behaviors, isn't it? So it's a lot of things to be done for an object to behave. But what is it we are interested in? Is ideally the object to invoke the behavior, isn't it? So if you could write code where you focus only on the things to be done by us rather than all the peripheral things, then our coding time reduces. So new age languages are like that. Be it Python, be it Scala, even though Python is an older language, be it Scala, be it Groovy, be it Kotlin, it gives you an ability to write syntax, ability to write code in very simple verbose like syntax, right? Non-template-ish and non-boilerplate as it's called. So for a person who is learning programming newly, for a person who is learning Android newly without having been exposed thoroughly to the Java fundamentals, learning Kotlin is a good way to go, because application development in Kotlin is very fast, simply because you write less code, as simple as that, right? But for a Java developer, he doesn't really need to spend time in learning Kotlin to learn something new altogether again. Even though it's not completely new and a Java developer can absorb Kotlin very quickly, it makes sense that first we learn Android development using Java first. Because we already know Java, we don't need to struggle with language and then runtime library and then framework. Right? If you are learning Kotlin, you have to learn Kotlin language first. And then you have to learn the runtime libraries of Kotlin. And then you have to learn the framework for Kotlin. Isn't it? Instead, if you already know Java, it's a no-brainer that you can just go for the Java stack itself. Having said that, there is an increasing trend of developers not appreciating the Java style of coding, and to make it lesser in volume, they're using Groovy, Scala, Kotlin like languages. What would be preferred, I would recommend, is you learn Android application development on Java first, become exceptionally good at it, then pick up Kotlin, because you already know everything. You have to just learn the language, syntax and its features. But that's all they really. It is not that it is more performant or more capable. Not at all that, right? Whatever you can do in Kotlin, you can do in Java. Right now, you can't do everything in Kotlin that you can do in Java. Okay, so in that way, going through the Java rigmarole is what I prefer for now because of our Java background. Anything else? Any other question in general about Android, about development, about jobs, anything? Yeah. For developing games. Yeah. So what should you learn to develop games? Well, one thing I want to be clear is Android foundation course that we are doing in Uttara, we do not address gaming, we do not address animation. Having said that, for you to learn gaming, you need to have, first of all, you need to learn OpenGL, right? You need to learn OpenGL thoroughly. You need to understand spriting in 2D, you need to understand 3D, you need to understand frameworks that are built for application development like Unity 3D, like Unreal Engine, right? All of these things are built for us as frameworks so that you can build your game on top of it. Application development for games is a different beast. It requires a different mindset, different way of working, different development styles, etc. And it requires a couple of years for you to pick up skills. You can actually learn, you can build a small game using Unity 3D or Unreal Engine in a couple of months. But for you to really dig deep into it, you need a couple of years of application development. Usually those who become gamers are those who are so passionate about games, not just playing, as many of us are, but for building. And they have already built some games on their own, and then now they take it forward. The number of companies who offer jobs in gaming is very, very less in comparison to those of in general enterprise application development. Having said that, usually for those who go into the gaming development world, there is never a choice. You see, that gaming development is so alluring for them that they have to do it. I know a person who is India's first end-to-end application developer, game developer, meaning who has built a game literally from scratch without using any framework. And it's a fantastic game actually. And he took, you know how many years to build it? 8 years. Couple of games. I forget the name of the game right now. I will Google it and I will tell you right away, right? And this guy, I mean, he's a known person, but he's not like a very close friend to me. He's a close friend to a close friend of mine, and I've met him a couple of times, and I'd called him to Uttara to, you know, interact with him and also with the students at some point in time. Today he's a big man, right? For 8 years, he simply sat and built games, and the same game. He built it and built it and built it, and when it was ready for market, his game was already dead because the technology had improved way much more. So he built the game again, and he built the same game for 8 years, and no money, no funding. Such are the people who build games. The fact that they have to build games is so important that he divorced his wife also. I'm not kidding. Exceptional guy, and unfortunately he had to give up his relationship also because he had to build games for 20 hours a day. He could not sleep otherwise. You know, it's like that. Unfortunately, that is the kind of people right now who can make into the gaming development world. Not saying so, there are a couple of companies who are from Uttara also who do Android application games, and if you know Android, you can go for it. But open source, I mean OpenGL you need to learn, and you need to have a passion towards game development. It requires a different pedigree and different set of efforts to be put in. I'm not very good at it, so I can't tell you first hand for it. Anything else?
How many ways to earn money if I have put in to build application?
How many guys?
How many ways to earn money?
How many ways to earn money if you are a good application developer? Well, for one, the most basic thing you can do if you learn Android well is you can get a job. That's number one, right? So if you get a job, what kind of salaries do you get? Well, again, because there are so many startups which have come into the fray to build applications, and many startups are not funded, you have jobs where they don't pay you any money, to 5,000 rupees a month, to 10,000 rupees a month, to 12,000 rupees a month, to 15,000 rupees a month, to even 50,000 rupees a month, right? You have a very wide spectrum. All kinds of companies have come, and we have tried to push people for all these kinds of companies depending on your capability. If you are a capable application developer in Android today, Getting a 50,000 rupees job is not at all a big thing. Not at all a big thing. Because there are not people who are good in Android available. There is a big supply problem. You know, when a company says, I want a Java developer, only 5 lakh people will apply. You see, because they are all trained in Java in some way or the other. So it becomes very difficult for the company to choose. If at all they say, I want an Android developer who has built an Android app and put it to the Play Store, 10 people will apply. So which means there is a big supply problem. So if you are good and you have pushed applications to the Android Play Store, getting a job is a no-brainer. That's one. Second, along with a job, you can start building your own apps and you can put it on the Play Store. And you can do 2 things, actually 3 things. One is you can build a free app, but you can embed marketing, ads into it. Very poor way of revenue generation, but you can do that. Where the application is running and below there is a bad bar which will keep throwing different things at you, and even more horrible is suddenly one in between screen will come where you are about to click something and one lady comes and say marry me, and horrible ads placement which is really bad according to me, but you can do that, and on clicks you earn revenue, right? The other way is to make your app a paid app. You release a free app, but with features which the users will get only if they pay. Or you release an app with full features, but they can use it only for a limited time. If they want to use it after that time, they got to pay you. And the payment can be 2 things there. One-time payment, $1, $2, etc. I mean, imagine, even if you make an app for 1 rupee and 10 million Indians buy it, that's 10 million rupees, literally, right? Which you can't earn in any other way as easily as this. And you can make, what is the bigger thing is, in-payment apps, which means you build games, you build applications, you build services where the customer has to pay regularly for you. Every month they have to pay you 1 rupee, imagine, and you have 10 million subscribers. So month on month, 10 million rupees, right? So these are the different modes in which you can make revenue. Third is affiliate ads, which means you build an app, like let's say you build it for students, okay? So you build a fantastic app for students and every student in India is using it, or every student in Karnataka is using it. 10 lakh students are using it. Now, you can go to institutes and you can go to colleges and you can say, look, 10 lakh people are using my app, your target segment people. You put an ad for institute, 10 lakh people will see it. I only charge you 50,000 rupees per month or something like that. And these are affiliate ads and target based ads that you can do. So these are the different ways you can build revenue. The good thing I'll tell you is you can be in a job and still do this. And once this becomes big, then you can drop the job. And the last 4th thing, the way you can make revenue is you can build apps for other people, right? You can become a freelancer and in your spare time build apps for others, take it from Elance or all these sites where you can bid for projects, start building apps, right? But for all of this, remember the prerequisite. You got to be a good application developer. You got to be good in Android. If you are good in anything today, you can make revenue. Certainly, and Android as well. Lastly, 5th thing, you can teach Android and make money in that also. Okay? So there are 5 different ways of making revenue. Anything else? Yeah. Good question. If you learn Android development, is it easy for you to pick up iOS development? The answer is yes, but still effort is required because iOS primarily works on Objective-C and Swift. Swift is very easy to pick up. Having said that, it is still built for a mobile ecosystem. So the form factor of iOS and the Android phones are all similar. The kind of sensors are more or less similar. The kind of architectural styles are similar. Not exactly. Many best practices are similar. So yes, it will definitely give you a fillip for you to learn iOS application development quickly. No doubts about it. But still, there is some amount of effort involved because iOS involves a whole lot of things which are very specific to iOS, right? But yes, definitely yes. From a zero, if you learn iOS, if you're an Android developer learns iOS, Android developer will learn faster. No doubts about it. Anything else? Yeah. Can you add your own things to runtime library? No, you can't. I mean, just like you can't add anything to the Java runtime library, You can't. But there are umpteen number of ways to put your apps, put your library in Git and all that and make it open source and pay for people to download. You can download it. If you root your phone, you can add anything you want. Anything else? Jainagar, you had something.
You said for doing more for for connecting directly for the open source that libraries which directly have the contact with OS.
Yeah.
Native applications have to be built.
Yes.
So, is it not possible to build this without using the native language and native application? Can't we build this using the Java?
You can.
Framework?
It depends on what you want to do. So the question is, when is it necessary to build native apps? Why can't you do what you can do in native apps using our Java apps, Java development? Most of the things you can do, but certain things where based on occurrences or events that occur in the OS, you want to do certain things. For that, you will have to bypass the Android runtime, and you will have to go to the OS directly. So there are many situations where you might want to do it, and if you want to do that, then you have to go the native library route, the native application development route. But it is not necessary for everybody to follow that at all, right? 99.99% of the apps on the market store is built on application framework, not using your native library at all. Anything else? What are mods? Mods is general term, right? Modifications given. It could be at the hardware level, it could be at the software level. So what are we talking about? Mods at what? Oh, Cyanogen. Okay, so you have Cyanogen mods. You have your so what do all these OEM guys do? The hardware people, they install Android OS, but they have to differentiate themselves from others, isn't it? Because if you buy an LG phone and you buy a Samsung phone and you have, what does the user interact with is the OS and the apps, isn't it? If they are exactly the same, then they will not worry about whether they will buy a LG phone or a Samsung phone. They will buy any phone they want, isn't it? But these OEMs want to create a stickiness. Today you buy a Samsung phone, tomorrow when you buy another phone, it should be Samsung only. When can they make that happen for you? When they give you a custom experience. So what do these OEM guys do? Is they build modifications or mods over the Android OS, wrappers over the Android OS, which makes it feel non-Androidish, if I were to say, which makes it feel specific to that OEM. So Samsung has what do you call that? Samsung wrapper mod is called what? TouchWiz. TouchWiz. It's called TouchWiz. HTC has their HTC Sense. Your LG has their own thing. Your Cyanogen has their Cyanogen OS wrapper or across Android, etc. So all of these mods makes the OEM different from other OEMs. That's all, right? But always as a customer, we would want less of this. These are bloats, extra things that are there. They slow down your processing and they can never be as good as what Android people do, which is the reason why what are popular devices to buy are pure Android devices, Nexus devices, and so on and so forth, right? But Cyanogen, you know the news yesterday, Cyanogen, no? They have stopped, they are venturing now into autonomous vehicle development. They are shutting shop on mobile OS because they are not able to compete. Anybody else? So now ask personal questions too, please, meaning about the course and about you and not general. Yeah. Yeah. So let's importantly focus on our course now. General Janta Android questions you can ask me anytime, but let's more so focus on the course. What do we learn in this course, right? So I generally at a high level told you there are only two things to learn: Android application development framework and your Android runtime libraries, right? So more specifically in this, what is it we will learn is we will be able to learn enough things to be able to build an app which interacts with a backing web app. All the intelligent apps that you see on your mobile phone are apps that interact with backing web apps, right? Like WhatsApp, for example, right? So when you send a message, it is actually being sent to a WhatsApp server, and the WhatsApp server pushes that message to the actual customer. So any intelligence can be provided in a mobile app if it interacts with a backing cloud app, right? So we will be building such an app at the end as the end goal and end project. We will build an app which has a UI, not non-animation-ish, but a UI which allows the user to allow inputs, which allows the user to scroll. It shows him lists, it shows him images, videos, whatnot, and navigation drawer, notifications, and perform actions in the background, and store data in your local database on your phone, synchronize with database in your backing web app. All of these things we will do, right? Ultimately, you will be able to build an app like any of the e-commerce application that you see, okay? Swiggy or whatever application that you see today, you can build such an app. That's the aim. That's the aim, and it will use material design, okay, of Android to build a nice, usable, interactive UI. It will use databases, it will use background, it will use notifications to prompt to the user when he is doing something else. It will interact with backing web apps, it will use HTTP calls, and we will use a number of standard libraries. All these I'm doing for the first time. We have never done it earlier. We will learn about your Firebase cloud services. We will learn about Dagger 2 to be precise, which is nothing but a dependency injection framework like Spring used in Android. We will learn retrofit for making HTTP calls. We will learn very important architectural style, design style, not architectural style, design pattern called MVP design pattern, and we will use all of these things to build our app, right? So an app which interacts with a backing web app which serves a business need. So our entire focus is on enterprise application development, right? So that's the aim of the course, and that's the end goal as well. We'll build a small e-commerce like application at the end and be putting it to the Play Store, and it will use all of these things. These are all very, very new and extremely necessary from an Android development point of view. Any interview you go in a good company today, they will ask you all these things, right? And of course, you will interact with the web app, which means we will learn JSON, JavaScript object notation to pass data, to send data and consume data as well. And yeah, I mean, a little bit of analytics, Google Analytics, etc. we will learn as well. And the idea is always I want to push more and learn newer and newer things every time I do a batch. So I started this course long time ago when I did only 10 to 12 sessions, and then it increased to 15, then it became 20, now it's at 35, and I want to add 10 more classes, right, to add these new things. So that's the basic aim of the course, all right? And to be able to build an app using latest practices, latest tools, and all these are not Android tools, they're extra. You download them, you use them, right, with the best practice design patterns, and build a nice app, push it to the Play Store. Your resume in Android won't be a document, it will be the app in the Play Store. That's it. If you go to any interview in Android, for an Android company, the first thing they will ask you is what apps you have built. So you just say Google Play Store, download this app, finish. That's it. Your entire interview will be about that app. You don't need to say I learned this, I learned that, etc. It'll all be about how did you build it, what practices did you follow, etc.